And in this part of the question, we are looking at the area that is enclosed by the x-axis and the part of the graph that is above the x-axis and bounded by the curve C. So we are looking at this region here. And from the previous part of the question, we have found the values of theta where the graph, this curve here, meets the x-axis. It is meeting at 2 points, but we have 3 values for theta. The 3 values of theta that we found in part 2 is when theta is equal to 0. And when theta is equal to 0, x is going to be equal to a times of 2 cosine 0. Cosine 0 is 1, so it is 2 minus this cosine 2 theta. It is going to be cosine 0 again, which is 1. So 2 minus 1, this is going to give me an a. And for the other value, that is when theta is equal to pi. When theta is equal to pi, x is going to be 2 cosine pi. Cosine pi is minus 1, so I have a minus 2. Then minus cosine 2 pi. Cosine 2 pi is 1. So 2 minus 1, this will lead me to a minus 3a. And the third value that we found for theta was 2 pi. So this will give me x to be equal to a times of 2 cosine 2 pi. Cosine 2 pi is 1. So this is going to be 2 minus away cosine 4 pi, which is also 1. So this is going to give me a. And if a is a positive number, which we have assumed when we are trying to draw part 1, so if a is a positive number, which means that this must be a, and minus 3a is going to be here. And to get a, we actually have 2 theta. Theta is either 0 or theta is going to be equal to 2 pi. So 2 values of theta gives me this point here. As for negative 3a, there's only one value, and that is when theta is equal to pi. And in order for us to work on the area of this region, it is going to be integrating from minus 3a all the way until a of y dx. And now we have a small little problem. The problem is minus 3a is going to be replaced by pi if we were to re-express this entire integral in terms of theta. But how about a? Because a can be either 0 or 2 pi, right? This is what I'm trying to say. Minus 3a is going to be pi. But we need to decide on a value to replace a. This is the x coordinate. So in order for us to replace a, we need to find out whether theta starts from 0, then going all the way until pi, or 2 pi, because it is going to be either the top portion or the bottom portion. We can actually do a quick test. Let's do a test that is of a value of theta that is in between 0 to pi. We check whether that value gives me one that is here or here. Then we will know whether we should start with 0 for a or 2 pi for a. Let's go for a value that is in between 0 to pi, let's say pi over 2. So if I were to let theta be equal to, let's say, pi over 2, let's look at the x coordinate of this point. So the x coordinate is going to be this, which is a of 2 cosine pi over 2. Cosine pi over 2 is 0. Then minus cosine of pi. Cosine pi is minus 1. So this gives me a. We'll look at the corresponding y coordinates, which is going to be a of 2 sine pi over 2, pi over 2. Sine pi over 2 is 1. So I have a 1 minus sine pi. Sine pi is 0. So I have with me here 2a, which means that when theta is equal to pi over 2, somewhere that is between 0 to pi, it gives me a point a to a. And since a are positive numbers, so that is, this point is going to be in the first quadrant, which means that from 0 to pi, it is going to go through this portion of the graph, which means that starting from 0 is actually a good idea for a instead of 2 pi, because it is going to be from pi, then going to here, then coming back to 2 pi, which will give me the negative portion of the graph. So this a here, from this, we have decided that it should be replaced by 0. And as for y, I'm going to replace it by theta. So y will be a of 2 sine theta minus sine of 2 theta. Dx we will replace, because from here we can find another version for dx d theta, and this is a of negative 2 sine theta. Negative negative becomes positive, so positive 2 sine 2 theta. So dx d theta, we are going to do a replacement. We'll make use of this to replace this dx here. So this will be a of minus 2 sine theta plus 2 sine 2 theta d theta. Let's expand this. So it is going to be integrating from pi to 0. A times a, this gives me a square. This times this, minus 4 sine square theta. This times this, plus 4 of sine theta sine 2 theta. And this times this gives me a plus 2 sine theta, again sine theta sine 2 theta, and this multiplied by this gives me a minus 2 sine square 2 theta. Okay, this d theta. So this is going to be integrating from pi to 0 of a square. Simplifying this, I will have a minus 4 sine 2 square theta. This and this plus 6 sine theta and a sine 2 theta. Then minus 2 sine square 2 theta d theta. And if I were to factorize out the negative, we will have a negative of integration from pi to 0 of a square, and this will be 4 sine square theta minus 6 sine theta and a sine 2 theta, then plus 2 sine square 2 theta, which is good because this expression is what we are supposed to be showing within the integral a square of this. But this negative is not what we are supposed to show. So applying the definite integral properties that we have learned, the definite integral can absorb the negative by reversing the lower and upper limit. So we'll go from 0 to pi instead. That will help me to absorb this negative, and a square of 4 sine square theta minus 6 sine theta, then sine 2 theta plus 2 sine square 2 theta d theta. And we have shown what the question wants me to show. This will be theta 1. So theta 1 is going to be 0. And this here, it should be theta 2. So theta 2 is equal to pi. Done.